Today we're going to look at the importance of application and database co-location to the users. With traditional databases and cloud databases that only support one write instance, users that are close to the application and database will get a good experience of the application, but users who aren't close to the application and database will get a bad experience of the application. Distributed SQL databases like CockroachDB give you the flexibility of where you place your database instances, ensuring that you can always be close to users and give them a good experience of your application. We'll look at two examples today. The first is going to be a traditional regional deployment of a database and application. This is a deployment of the application and database in the States, but we're going to focus on the experience of a European user of that database. We can assume that because of the co-location of the US user, they're going to get a good experience. Next, we'll move on to a globally distributed database, but a regionally distributed application. So we're not co-locating the application and the database for all users. In this example, we'll see what the experience is like for a European user whose data resides in Europe when the application isn't based in Europe. And then I'll update the application so that it is co-located, and we'll see how the experience improves for European users. We'll start with the first scenario. I'll deploy a single region deployment of CockroachDB in US East 1. I'll export the URL and I'll use it to create a database and a table. The table has no locality information attached to it, so there's no regional topology pattern applied here. It's just a table, and it contains product information. Each has an ID, a random name, a random market, currency, and amount. Next, I'll spin up the application. I'll apply the URL as a secret, and I'll deploy a single instance of the application to Ashburn, Virginia. With that up and running, we can now start to make requests. I've written a simple command line tool that will make 10 requests as quickly as it can against a given URL. This is the deployment URL of my service. I'm asking for products in the UK market where the price is between 10 and 20. And we're seeing latencies of around 95 milliseconds, 97 milliseconds. So around 95 milliseconds to make a request. If I make a request for US products within the same price bracket, we're going to get the same kind of performance because it's all coming from one database. I'll tear down that application, I'll tear down the database, and I'll tear down the cluster, and then we'll begin scenario 2. For scenario 2, I'll spin up a 3-region CockroachDB cluster across the States, Europe, and Singapore. With that set up, I'll deploy the application again. As with the last scenario, I'll deploy a single instance of the application to Ashburn, Virginia. This will simulate what we have in our basic architecture diagram, where the application only exists in the States. I'll connect to the database quickly and show you how data is pinned, just to give you an idea of the paths that requests are going to have to take through the system in order to serve European data. With this query, I'm showing the ranges for a given row, and I'm doing it 3 times. One for a US East based row, one for an EU Central based row, and one for an AP Southeast 1 based row. And we can see that for US East 1 data, it's using replicas 2, 3, and 4, but not any of the other replicas, so data is pinned to US East 1. EU Central 1 data is pinned to replicas 12, 13, and 16, and AP Southeast 1 data is pinned to replicas 5, 6, and 7. There's no sharing of data between these regions because I've separated them into their respective superregions, which prevents data from leaking into other regions. If an EU user makes a request for US data, their request will hit the application and then go to the US database before the data is returned to them. If they make a request for European data, which is pinned to the EU, their request will hit the application, fetch the data from the EU database, which will be returned to the application before being returned back to the user. And that's a total round trip of around 22,000 kilometers. Let's see what that looks like in latency terms. First, I'll fetch US-based products. And the latencies are similar to the ones we were seeing before when the application and database were just in the States, and that's expected. However, what you might not expect is what happens when you pin data to a location and the request paths that has to make as a result. Now I'm going to ask for UK-based products. You'd be forgiven for thinking you'd get lower latencies for doing this request, but because of the request path I've just shown you, I would expect higher latencies from this request. And we're seeing around 100 milliseconds longer because of the extra pond hops the request is having to make. Just to reiterate, that request has gone from me in London to the Ashburn, Virginia application, to a Frankfurt-based database, back to Ashburn, and then back to London. The situation only gets worse as you get further and further away from Ashburn. If I want Singaporean products which are pinned to Singapore, my request has to go from London to Ashburn to Singapore, back to Ashburn, and then back to London. Each request is taking on average 340 milliseconds. Let's scale the application out now so we have an instance running in London, Ashburn, and Singapore, and see how that improves the experience for an EU-based customer. What we have now is a co-located application and database that's close to users of every region that accesses our application. Now my request for UK market data will go from me to the Frankfurt application, to the Frankfurt database, back to the Frankfurt application, and then back to London. Let's see the result of that in milliseconds. Now we're seeing reliably lower latencies, and the closer I get to Frankfurt, the lower the latency will be for me. If I spun up a database region and application in London, I would get even lower latencies. But for the majority of European users, this is a great experience. With traditional single instance databases or any cloud-based databases with only one write instance, you don't have a lot of flexibility when it comes to positioning your data and your applications closer to your users. There's always going to be markets that are underserved by your application simply because of their proximity to it. With CockroachDB, you have a lot more flexibility as to where you place your data in relation to your application and your users. This allows you to be closer to your users and give them the best possible experience of your application. With the right combination of database locality and table topology, you've got a powerful combination of tools that you can use to serve your customers.